Good morning. I'd like to thank everyone for joining us today. This morning, my name is Jeff Sharp. I'm the director of the School of Environment and Natural Resources and part of the team that hosts the EPN. This morning, we continue our tradition of collaboration between the Environmental Professionals Network and the Water Management Association of Ohio, or pronounced in acronym form WMAO, in the month of March, focusing on critical water issues facing the state of Ohio. This year, we appreciate the Ohio Water Resource Center and TerrAqua, an Ohio State student organization, joining us in the development of this program, which I know started back in September or so, and I know they've spent a lot of time planning. Over the course of this morning, you will hear from leaders from each of these groups, including Craig Smith, board president of WMAO, and Karina Peggau, student president of TerrAqua, in a minute, and Dr. Linda Weavers with the Ohio Water Resource Center later in the session. I do want to give a special shout out as well to Dana Aliskowitz, Eugene Bragg, and Riley McDonald, who on behalf of those organizations have worked with our EPN team to develop this emerging contaminants program over the past 7 months. Thank you very much to that planning team. We are so excited to welcome an array of emerging water contaminant experts to Ohio State. Please take a moment to read the bios located in the program brochure on your table. On the back side of the speaker bios, you'll note the list of program sponsors for today. These companies help to make it possible for us to bring the many expert presenters here to Columbus. And on the next page, you'll see the list of those individuals who, through their online registration process, helped to sponsor today's participating students. As many of you know that are regulars at the EPN, and if you're new, we really try to create an opportunity to interact Ohio State students with environmental professionals in the field. Would all the students in the room please raise your hand? So if you have a chance, If you have a chance to interact with some of the students, many of them are on track to graduate this spring, and so they're always looking for helpful tidbits on how to get a job or opportunities you might be looking to fill. So please network them as best you can, and students, be brave and step up and introduce yourself and have a good time. I've heard from some of our regular EPN attendees who regrettably could not participate here in this room today as they are attending the Ohio Wildlife Diversity Conference, which is happening across campus at the Ohio Union. For those of you that follow events here at Ohio State, we try to coordinate and sort of make sure we don't overlap with these kind of things, but we apologize for those of you that had to make a decision between participating in that annual conference and today's. Next week's spring break, so we're all kind of sort of pushing everything into this week before next week when everybody sort of disappears. Today's program is a unique and excellent opportunity to give students professional development experience on some very relevant and real-life environment and natural resource issues. Despite the very busy time in their semester schedules, we are lucky to have students in attendance today from various majors and degree programs at Ohio State. To provide some comments on today's activities is Karina Peggau, president of TerrAqua Student Organization. As I mentioned before, Karina and other members of her student executive board have been meeting with WMAO, the Ohio Resource Center, Water Resource Center, and EPN planning team since September. We greatly appreciate their involvement and participation today. For some background, Karina is an undergraduate level senior majoring in earth sciences in the College of Arts and Sciences with a focus on earth systems. She is from the Chicago suburb of Naperville, Illinois. She has been part of TerrAqua for 4 years, serving as an executive member for the past 3 years and becoming president in spring 2018. In addition to her involvement with TerrAqua, she serves on the planning committee for Ohio State's Green Week, called Time for Change Week, and she works at the Bird Polar and Climate Research Center in the Education and Outreach Group. Please welcome Karina.
Wow, thank you so much, Jeff, for your thoughtful comments. It's a delight to be here this morning. It's my absolute pleasure to be here today representing the Ohio State University student organization, TerrAqua. For those of you who may not have heard of TerrAqua, we are an undergraduate student organization devoted to providing learning opportunities for people interested in water quality and conservation. We are a student affiliate of the Water Management Association of Ohio, and members of both TerrAqua and WMAO are in the audience today, so please say hello. We have educational presentations, certification trainings, through the Ohio EPA and Sierra Club, volunteer and social events, and field trips to various sites in the greater Columbus area. Some of our activities include stream quality monitoring, partnering with local residents for water quality management workshops, touring behind the scenes at the Columbus Zoo and Aquarium, and networking with professionals in the field to better our understanding of the world of water. Emerging contaminants should be a concern for more than just aquatic professionals. It affects everyone, people of all ages, ethnicities, and professional backgrounds. For example, researchers at the World Health Organization have found microplastics in tap water and in 90% of the bottled water we drink, as well as in the food that we eat. More than half of the nitrogen found in our DNA, proteins, and cells consists of the same synthetic nitrogen that we see in fertilizers. And dust from harmful algal blooms can cause respiratory problems in nearby areas, while toxins from these blooms can cause problems for human and animal health through the recreational, municipal, and domestic uses of contaminated water. Water is an essential part of our lives, and we depend on it for food, energy, product manufacturing, and hydration. Because of our dependence on water, we must take measures to understand how to protect it. TerrAqua and its citizens approach this issue through water quality analyses and citizen engagement. We strive to understand the quality of the water around us, the role we play in maintaining its health, and how we rely on it for our personal uses. We interact with professionals, citizens, and other students to learn more and spread awareness about the importance of water quality management. If any of this appeals to you, we're always looking for bright minds and new faces to help us in reaching our goals of bettering the quality of the water in the world around us. Feel free to reach out to us via email, join our Facebook group, or come talk to me after this program. We welcome any and all students. TerrAqua has so many amazing opportunities to get involved in science and education, but none of these opportunities would be possible without the collaboration of our executive board. Hannah Commune and Riley McDonald are in this audience today, and our treasurer, Melina Mallory, could not be here today. But these three are women who I have worked with for the past year, and they are the future leaders in water science. It's been a pleasure to work with them. Eugene Bragg, I have to give a shout out to him. He has been the TerrAqua advisor for several generations of officers, and he has been involved in every part of this organization's existence. From planning to attending every meeting to helping me write this speech, there are few advisors who are as dedicated to their student organizations as Eugene is to TerrAqua. I am extremely grateful for his guidance over the years. Thank you, Eugene. To give introduction for today's program and of our keynote speaker, I would like to welcome Craig Smith, the president of WMAO and an environmental specialist with the Ohio EPA's Division of Drinking and Groundwaters. Craig has been with the EPA for over 20 years and the president of WMAO for 2, and has been a leader in the world of water for more time than I've been alive. It has been a pleasure. It has been a pleasure to collaborate with him this year, and I'm delighted to introduce him to you today. Please welcome Craig Smith.
She warned me she was going to say that. It's true. Thank you, Jeff and Karina. And before I begin, I really want to thank Joe and the EPN staff, TerrAqua, the Water Resources Center, and the Ohio State University for all that they've done to make today's program possible. It's my pleasure today to represent the Water Management Association of Ohio, as Jeff said, WMAO, at today's event. For those of you who are not familiar with WMAO, we're a statewide organization of water resources professionals representing all aspects of water use, conservation, and management. Our members come from the public and private sectors, colleges and universities, volunteer groups, watershed groups, and students. We share one passion, our shared water resources, and the desire to share what we know and what we've learned with others, and in turn learn from them. Today's session covers a broad and evolving topic, emerging contaminants. The term emerging is a bit misleading. Cyanobacteria have been producing toxins for who knows how long. Per and polyfluoroalkyl alkyl substances have been produced and used in a wide range of products and industries for decades. Studies have found traces of insect repellents, antidepressants, sunscreens, birth control products, even caffeine in surface and groundwaters across the country. And as Mr. McGuire said to Benjamin Braddock in The Graduate, there's a great future in plastics. I don't think today's discussion of what Mr. Braddock had in mind in 1967. These contaminants have a broad impact on water resources management. As you are aware from reporting, many of these compounds have or may have a negative effect on human health and the overall health of our environment. The impact to water resources management is extensive. These new contaminants may affect how we treat wastewater, manage our stormwater, treat drinking water, manage our reservoirs, even to the extent of how we collect our samples. And as our ability to detect these compounds at even lower concentrations, and as our understanding of their effect on health and the environment at these levels continues to grow, it seems that new contaminants will be emerging for quite a while. I have the honor today of introducing today's keynote speaker. Amy Klei has served as chief of Ohio EPA's Division of Drinking and Groundwaters since March of 2018. Amy's been with the agency since 1998, working on many different aspects of both the Safe Drinking Water Act and the Clean Water Act. These include serving as manager of our division's harmful algal bloom section, Lake Erie coordinator in our Division of Surface Waters, and the Division of Drinking and Groundwater's Safe Drinking Water Act, Clean Water Act coordinator. Amy holds a BS in geology from Denison University and a Master's of Environmental Management in Water Resources Management from Duke University. Go Blue Devils. In March, yes. Please join me in welcoming Amy Klei to the podium.
Well, good morning, everybody. Craig was paid to say those nice things about me, so I appreciate that. And I thought of one thing to soften the burn that you got from Karina, and that was emerging contaminants have been around longer than Craig has been, so soften the blow a little bit. Well, thank you. I appreciate the opportunity to be here, and I know we had originally hoped that we could get our new director, Lori Stevenson, here. So for those who were expecting her, and I'm your stand-in, so you paid $10, at least you're going to get a good breakfast. So I'll do my best. But I think with, as Craig pointed out, my experience with emerging contaminants from a regulatory agency perspective is what I hope to bring to the table this morning. And we have a great lineup of speakers coming later this morning to go into some of the nuts and bolts of several of the key topics. But there are so many challenges with emerging contaminants, and how in our different seats, whether we're sitting in the researcher seat, or we're sitting in a manager seat, or in a legislator seat, or the public seat, how do we deal with these issues as they're coming up? So I like visuals, so we're going to use some slides to get through today. But I like to think of emerging contaminants as a bit of an iceberg. And there is the known part that we have, and that's the part above the surface. And it's the things that we can put a name on it, put a number to it. It's things that we have analytical capability to start naming, and this number is expanding. More and more of that iceberg is becoming visible. And the other part, though, is what is beneath the surface. And I think anybody who works in this probably understands the ratio of what we know to what we don't know, and how do we deal with the unknowns. And not only how do we deal with them as we study and we decide how to approach emerging contaminants, but how do we communicate to the public and to each other on the unknown part. And I think that's what makes it so exciting. And to me, one of the best parts about this morning is all the young people in the crowd. Craig, you're still young to me. But all the young people in the crowd, because we're going to need creativity and innovative thought and solutions. So we're going to do our best on our way out to implement as many of those, but we're going to need a lot of you folks here in the room to help us with these issues. Public interest and expectations has changed. I work in the drinking water world right now, and the expectations, I think, of the public's expectations and demands of what is expected in their drinking water, what it was 5 years, 10, 15 years ago, is not the same. And I think some recent events, you can look at the Flint, Michigan case in Ohio, the Toledo case. People are paying more and more attention. And even though we have some of the safest water in the world here, I think these demands of what we're seeing in the water are over top of how we deal with emerging contaminants. And I'm going to use a prop this morning just to keep this lively. And this is the March 2019 National Geographic. I got this from my younger daughter because the articles are great and just trying to expand her mind. And I'm flipping through, I'm like, this is great. There's a cover on, I think, We Are Not Alone is the cover, something with aliens and science and space. And, oh, there it is, sorry. I flipped to page 17, and there's an article, A Wake-Up Call on Water Quality. I'm like, really? This is last night as I'm prepping for this talk. And this is amazing. And so I'm reading through it, and there's a key point in here that they make in the article. Everyone has a right to clean water, no matter what you look like, how much money you make, or which political party you favor. And I think that is more relevant today. And part of the article, too, was, I'm like, well, this isn't about emerging contaminants, is it? And they're talking about the number of systems that we have in the country that have violations of the Safe Drinking Water Act. Okay. And then I'm like, all right, it's not about emerging contaminants. Oh, wait, there's a whole article on PFAS. Okay. So very timely. The last thing I'm going to say out of this article is lead makes headlines, but it's not the half of it. The more we look for pollution, the more we'll find, and the list of contaminants is long. So, National Geographic, March 2019. Anyway, drinking water seems to be on the front line. When we find emerging contaminants, this is one of the first places that we hear the discussion. How do we treat for it? And it's, I think, because of the Safe Drinking Water Act and some of the processes that are there for identifying and monitoring for and naming and claiming some of those emerging contaminants, which is why we see it in drinking water. So lots of challenges today. The first step is to get the analytical methods, and we've got a lot of great work going on, refining those methods, coming to standard methodology, getting the data. How big of a deal are some of these? Are they occurring nationwide? Are they in drinking water? Are they in fish? That type of data. And then if it's there, so what? Does it have health effects? How do we quantify those? And so these are real challenges that we have. And then from a regulatory agency perspective, while all those issues are evolving, we don't have the regulatory framework with which to respond when we find something. So, and then when we find it, the treatment technologies are usually, there's a lag and a gap between when we start to develop those, and then how do we deal with the sources. So there's kind of a stepwise process that we get. And so from, if we find it in drinking water, what does that number mean? What do we tell the public? How much should we have that community spend on treatment for a contaminant that maybe we don't know enough about the health effects yet? And then the other part is this, just even the part of the iceberg that we can see is massive. I think TSCA has over 80,000 chemicals or chemical compounds that are approved for use. There's thousands of new chemicals that are considered emerging, and hundreds are entering the market every single year. So how do we decide to prioritize and use our valuable research dollars, or where, as a regulatory agency, how do we move our resources around? So I think what is helpful, and I'm just going to try to do this as quickly as I can, but to understand the regulatory processes under the Safe Drinking Water Act. And how do we go from identifying new contaminants to regulating them? And these are some key terms that you'll hear, I think, in some of the other talks. So bear with me while I get a little regulatory nerdy for a minute. You'll get science nerdy later, but this is my turn to go nerdy. So under the Safe Drinking Water Act, one of the key steps, and this was in the 1996 amendments to the Safe Drinking Water Act, requires US EPA to publish a contaminant candidate list. We'll just call it CCL. And this is where they kind of name and claim all the emerging contaminants that they have a concern. they use this list to prioritize testing and research dollars and monitoring. There's a side program called UCMR, Unregulated Contaminant Monitoring Rule, and every 5 years, US EPA goes out and monitors for 30 of these contaminants that are on the CCL, trying to get more occurrence information. So that's it. They're designed to work in concert, and UCMR monitoring supports what we know about those candidate contaminants. And then every 5 years, US EPA needs to look at least 5 of the contaminants that are on the CCL and do what's called a regulatory determination and decide, is there enough information to move this into rulemaking and regulate this contaminant? And part of that determination process is to look at, does it occur at enough frequency around the country? Does the contaminant cause adverse health effects? And would regulation provide a meaningful opportunity to reduce those health effects? So if it clears those hurdles, then they work on setting MCLs or formal drinking water standards. And you'll hear MCLGs and MCLs, and there's an important distinction between these. MCLG is a maximum contaminant level goal. This is not a regulatory number. This is sort of the aspirational number in some ways, where there is a zero health risk to the most sensitive populations. Then, when they set the MCL, they have to look at what is feasible. Are there treatment technologies available? Can they monitor to that level? And then there's a cost-benefit analysis that's done. So when we throw terms around like MCLs and contaminant numbers, it's important to know what is behind those numbers. And too often, once we put a number out there, whether it's an MCL or a HAL, which I'll talk about in a minute, people see that as the bright line in the sand, that is the number. But there's a lot behind what those numbers mean. So I mentioned health advisory levels. You'll hear more about those today. Those, when in drinking water, if we don't have a regulatory number like an MCL, the US EPA can issue health advisory levels. They're non-regulatory, although they often get used in a regulatory form, based on available data where we won't have health effects. And so we use those as guidance. And you'll often hear these in 1, 10-day, or lifetime health advisory numbers. That's another part of the verbiage that gets lost when we're talking about numbers out there and with regulatory contaminants. The 1 and 10-day are designed to protect children for exposures for those time limits, and then lifetime is a number below which adults could consume that contaminant without health effects. So there's a lot to a number, but pay attention to it. So to give a little background leading into, like I said, more of the detail, that's it for the regulatory nerdiness is off, okay. We're gonna talk just briefly about some experience we've had in Ohio with harmful algal blooms, and then some of the new things going on with PFAS to kind of lay the framework for our future discussion here. But Ohio has been at the forefront for harmful algal blooms. We wasn't really our choice. We had a lot of things go on, and that picture on the top right is from Grand Lake St. Mary's in 2010. And that's our state's largest in the lake. We were looking into harmful algal blooms probably starting around 2006, learning more about the cyanotoxins. And again, at this time, the analytical methodologies were just getting developed. We didn't have any labs in the state of Ohio at that time that could even run the analysis for the potential cyanotoxins. And it was through US EPA's Inland Lakes, National Inland Lake Survey. That sample was collected in 2007. We got the results in 2009 that kind of first raised the red flag that we may have cyanotoxins in some of Ohio lakes. So we moved very quickly, I think, as a state in response to this. In 2011, we got our main agencies together, Ohio EPA, Ohio Department of Natural Resources, Department of Health, and said, you know what, as a state, even though we don't have a federal regulatory framework or something to point to, we need to collectively come together as a state and say, how are we going to respond to these unregulated emerging contaminant? So we put out a state strategy, and every year have refined it and improved it as the science has been refined and improved. We didn't know at the time whether or not this was going to be an issue for drinking water. We were hopeful that conventional treatment would be effective, but we didn't have the studies. And we combed the globe looking for information. We had conversations with CDC, we talked with US EPA, we talked with other countries, and that went into our state response strategy where we had to come up with, if we have detections in drinking water, what kind of number are we gonna use? So we actually used the World Health Organization. They have a guidance out that we use their initial threshold, and we adopted Ohio threshold numbers for response. So in 2013 and 14, we had drinking water detections. And the 2014 is the Toledo event that was kind of a game changer with how we deal with this emerging contaminant in Ohio. You'll hear a lot more about that later in Dr. Carmichael's talk. But it drove legislative action. And we, in 2015, had Ohio Senate Bill 1. And then at the same year, later that spring, US EPA released a health advisory level. And this was a 10-day health advisory level for microcystins and cylindrospermopsin. So you can kind of see the sequence of how things are coming out. It's significant that that's Ohio Senate Bill 1. The Senate bills are numbered from when the session comes on. And the fact that this was the first Senate bill that went through on an environmentally based issue it should not be lost on the significance of that. So in Senate Bill 1, it called on Ohio EPA to be the state's HAB coordinator, to write rules, and to formally regulate through state measures cyanotoxins at water treatment plants, as well as a number of other measures to start addressing the source. And then in 2016, we had our rules go into place, and we've been working very hard with our water systems. And I will say I think it's been a very successful approach. We have not had any drinking water advisories due to cyanotoxins since the 2014 event. Our water systems have done an incredible heavy lift to meet this. We have learned a lot as every 6 months the science about cyanotoxins evolves. Our knowledge about about treatment technologies. And I think for us having dedicated staff who, I think we have our whole HAB team here today, has been a huge part in staying on top of that information and then conveying that back to our utilities. Consistent messaging with emerging contaminants is a big deal. It's confusing even within a room as intelligent as this one, let alone the general public. So words matter, how we communicate and respond. One of the benefits of our strategy, I think, was setting clear expectations for our utilities, for our governmental partners, and for the public. So if we found something in the water at X number, we all knew what the response was. And I think that's one of the challenges that we're dealing with PFAS and some of these other emerging contaminants now. Two other big things to mention here was coordination with research, getting the regulatory community with the researchers together to talk about priorities. How can we strategize and prioritize that work so that when that research project is done, it is immediately applied at a water utility or immediately used by an agency like ours to make better decisions. And that's been a really important thing that we've learned under the HABs that I think we're trying to translate into our other emerging contaminant work. And then I also want to acknowledge, as a state where we don't have all of this background and information, the work that US EPA ORD folks and the office that they provide with emerging contaminants is absolutely invaluable. And we reached out, and we are so fortunate here. I know this is Columbus, but we happen to have an ORD facility in Cincinnati in our backyard, and I don't think we often forget how lucky we are to have them there. So, am I getting short on time? Okay, good. So I'm going to just touch briefly on kind of the next frontier for us in terms of emerging contaminants, and that's PFAS. And you'll hear a lot more about that today. It's a hot topic. First used in the 40s, a synthetic chemical. It has unique properties that make it work really well. And I tried to put my sticker on my jacket, my fancy new stain-free jacket, and the sticker would not stick to my jacket. So some of those unique properties that make it work so well also make it a challenge in the environment. Little toxicity data for most of the PFAS compounds. We do know the most about two called PFOA and PFAS. They've been around the longest. Like I said, you'll hear a lot more about this in detail a little later. But what do we have to deal with when we find these chemicals? We don't have any MCLs. It has not gone through that process. We only have a lifetime health advisory for combined PFOA and PFAS that US EPA issued. So that's what we have to work with. So there's my joke. Stick around, learn more from Dr. Lindstrom. As I said, this is a hot topic. Just, was it 2 weeks ago, US EPA released their long-awaited action plan for PFAS. And I was fortunate to be, May of 2018, they hosted a leadership summit on PFAS in Washington, where kind of kick-started this, had people from almost every state there. And then we've been waiting on this action plan. So the action plan was just released, and there is a commitment from US EPA to move forward in developing an MCL for PFOA and PFAS. The next two bullets there about designating PFOA and PFAS as hazardous substances under federal programs such as CERCLA or Superfund, developing interim groundwater cleanup recommendations. Those two bullets are going to be key for when we find it and we need to go and do cleanup. It's going to give us some tools to go after doing the cleanup. PFAS was included in UCMR 3, so the third round. UCMR 4 is underway with the monitoring, but in the next round of UCMR 5, they will include additional PFAS. So we will be getting even more information on nationwide occurrence in finished drinking water. US EPA is going to continue to support states in their enforcement cases. And then this last point is huge, developing a risk communication toolbox. There is a lot of, like I said, the challenges of communicating on emerging contaminants are immense. And in a case when we don't have this federal clear guidance out there, and we have lots of different states and entities doing different things. And one of the challenges, for example, with PFAS is while there is a federal HAL out there for PFOA and PFAS, other states have gone and set different numbers. And so how do you communicate that to the public where you have different numbers acceptable on one side of the border or the other? This is one challenge as a state agency that we're deeply engaged in and concerned about moving forward. So what are we doing in Ohio? As you know, we have a new administration in. We are working to get them up to speed on this and many issues. But our initial efforts are focused on that tip of the spear in some ways, which is the drinking water aspect of PFAS. We're coordinating closely with US EPA and other stakeholders as that national policy gets developed. And then communicating with our researchers on the method development, treatment technologies, best management practices. It's really important that we stay in touch and get that targeted research done. And then another point is we have a laboratory here in Central Ohio, and they are developing the analytical capabilities. I think this should be coming online soon to run our own PFAS analysis so we don't have to ship to 5 states away to get analysis. So with that, I just have a few final thoughts and maybe some challenges as we to challenge you to think about as we go through and bring our esteemed panel folks up. How do we focus and integrate this research? Time is of the essence, really, with getting the results and getting results that can be applied and helping from a regulatory hat here, giving us the information we need to make better decisions now. So health effects, treatment, fate and transport. The last thing we want to do is solve a problem in like drinking water with PFAS and translate it and move it into air or move it into biosolids or into the groundwater. So that's one of the things we're looking very closely. It starts as a drinking water program, but it can't stay as a drinking water problem. This PFAS and a lot of emerging contaminants cross over into media, and that's why it's so important that we communicate and coordinate across programs. One of the things from my hat as a drinking water side is how do we support more resilient communities? I talked about the iceberg. How do we better protect our communities and have them be resilient and prepared to deal with all that lies below the surface? And we have a new asset management program, getting more capable systems that are prepared for the future challenges. And then our source water protection program, we are going to prioritize going forward as well. We can't think of a better way to protect our communities against the unknowns than to protect their sources. So could all the students raise their hand again? If you had your coffee, you're still awake, you're with me? Okay. We need creative problem solving and innovation. Like I said, we'll do our best to get things started, but we need to think about things differently. It's not the same world it was 10, 20 years ago, and what will it look like in 10 and 20 years going forward? So that concludes my talk.
Thank you, Amy. That was a great talk. I feel a little daunted right now by some of these problems. We are going to have a panel of 3 speakers now. Maybe I will call them up and talk to you a little bit about their areas of expertise. So our first panelist, so what we're going to do is we're going to have a panel, and these 3 panelists, and we're going to have a bit of a moderated session, and then we're going to allow you to ask questions. So if you have questions, please think about them and hold them for about 15 or 20 minutes. So our first panelist that's going to be coming up this morning is Wayne Carmichael. So Wayne Carmichael is Professor Emeritus at Wright State University. So his area of focus is aquatic biology and toxicity. He spent many years in the Department of Biological Sciences at Wright State University. Significant expertise in toxin-producing cyanobacteria, working in this area for over 40 years. So Wayne, welcome. Our second panelist, and so this, as you heard Amy's talk, this is the HABs. So we, here in Ohio, have learned a lot about HABs and have made some significant and great progress in that. So our next speaker is Dr. Andy Lindstrom. And so he is a research physical scientist at the U.S. Environmental Protection Agency in their National Exposure Research Laboratory. He has been at EPA since 1990, and he has significant experience in a range of different areas, most recently spending a lot of time with the PFAS compounds. And trying to develop understanding of where they're located and what's going on in that area. So that's kind of the area that we're gaining expertise very rapidly in. Our third speaker this morning is Sarah Lowe, and she is Great Lakes Regional Coordinator for the National Oceanic and Atmospheric Administration's Marine Debris Program. And so that is an area that was not even touched by
I meant to talk about that.
Amy
Sorry,
Klei, but I
Sarah.
think that reflects kind of where the relative icebergs are and how much we know about kind of what's underneath the surface. And for the microplastics, it's very, very little. We're just learning about that. So Sarah Lowe is working as a regional Great Lakes coordinator for the Marine Debris Program in Oak Harbor, Ohio. So she's been the Great Lakes Regional Coordinator for 9 years, and she joined NOAA in 2009, originally as a Knauss Sea Grant Fellow. So we want to have a panel and talk about these issues, and I think it would be good to lead off in how do we think about these compounds, and are there best practices that we can take from what we've learned about HABs to these other emerging contaminants? So I don't know who the best person to answer that would be. If Amy, you have the mic there, if you want to be the first one as to how to deal with that, and maybe we'll pass that off to some of our experts, particularly Wayne, in your expertise in this area.
Yeah, that's a real challenge. How do we can repeat the question? I'm just kidding.
What are some lessons learned, and can we translate our lessons learned in one emerging contaminant to another emerging contaminant and get better? Because it seems as though we may be dealing with quote, emerging contaminants for a long time to come.
I sure hope so, that there are some lessons that we can learn. As I said, we don't have a lot of time to do these one at a time and have to learn some of the same lessons over. So I think there's probably a lot of lessons through some of the analytical approaches. How do we sample for these? And then I think there are also some lessons to learn in how do we, whether it's coordinating with those results, how do we work with those entities, those regulatory groups that are going to be impacted by what we're learning through the research, and then some of the best management practices that translate to whether it's handling of these contaminants or even some of the source control solutions. So.
Okay, well, you hear me? Good. Yeah, it's hard to know exactly where to start, but let me just say, the HABs, when I was, emerging issues, clearly HABs aren't emerging. When I came to Wright State in 1976, one of the first lakes I went to see was Grand Lake. It was eutrophic. It wasn't hyper-eutrophic. There were no significant cyanoblooms, but there were a lot of blooms. Clearly, I could see that something was going to happen down the road, but it never happened. And as I started the research program, it was really internationally that these HABs were becoming more of an issue. South Africa, Australia, even Europe. And so that's where I spent my time. China, so we have that background. I suppose I could have, kept beating the bush and say, well, you've got to do something now in the 70s and 80s, or you'll find yourself where you are now in the 2000s. But there are very many similarities between the HABs. You talk about, maximum concentrations. Well, maximum concentrations for microcystin differ with almost every state and every country. But we set the guideline based on World Health Organization. And World Health Organization has much different guidelines. We're looking at, World Health Organization looks at developing countries. We took a much more conservative approach to setting guidelines for the World Health 1 part per billion. And there's no doubt that that can creep up as different countries and different states look at it differently. But it provided a starting point. So I think those are the issues. The biologicals obviously are a bit different than, PFAS and the plastics and everything else, but they all kind of fall into the same realm. You approach them the same way, you understand the problem, you develop analytical methodologies, you do your monitoring, you use those methodologies to document their existence, you start looking at risk, you start looking at poisonings. In the case of cyanobacteria, we had no problem there. We had animals dying everywhere, and people as well. So that sort of pushes the issue along as well. So I think from your perspective, where I'm at right now is really encouraging you in the natural resources, in the economic area, ones who set policy, one who has to convince the public that these issues do need to be addressed, and they really need to be addressed at the base level. It's one thing to have a nice monitoring program in Ohio, but until you address nutrient enrichment and how do you slow that process or even reverse it, you might as well just get used to the fact that your lakes are going to be green. So with that, maybe I'll.
So I'm at heart an analytical chemist. So I look at these things through the lens of methods development and analytical technologies. And I'm sort of tangentially associated with some of the laboratories at ORD and at Research Triangle Park. Dr. Neil Chernoff and John C. Lang were doing harmful algal bloom research. And they come to us asking us, how do we measure these materials? They're very complicated. They change. There's different conformational structures that are there. And the thing that I'm seeing that I think maybe unites a lot of this together is the need to develop these new analytical approaches and methods to be able to accurately measure these materials. And it's important to realize that they'll change according to pH or temperature or how they were stored. Getting analytical standards is very difficult because of the way they're produced and the purity associated with them and the co-contaminants that are there. And something that I might touch on a little bit later in the talk that I'm going to be giving with about the perfluorinated compounds is sort of the rise of high-resolution mass spectrometry to help us understand what's happening out there in the chemical space. So I'm not sure how many of you have been aware of the advent of high-resolution mass spectrometry and how prevalent it's becoming, but that's really the key to helping us understand what's in the environment. And Amy talks about the iceberg. Believe me, it goes way, way under the waterline. There are just so many compounds out there, it just kind of blows your mind when you look at it and you understand exactly what's out there and the proportion of what's known, very little to what's unknown. So it's kind of scary.
Morning. I was just going to add onto a little bit of what was said in terms of methodology. Certainly, microplastics methods in terms of identification and also associated contaminants on microplastics. Those methodologies are certainly developing, and it's something that I think is consistent with all of these different contaminants. But there were a couple things from Amy's presentation, too, that certainly are very relevant for microplastics as well. One of those being consistent messaging. So messaging is really key when these things are first discussed in the public and when they're more widely seen. So that was something that is definitely very key for the microplastics issue as well. But also the community involvement. So I think it was touched on a little bit about this is going to take a wide variety of groups working on the issue to tackle it. There isn't a silver bullet solution. So having a lot of groups at the table to come together to talk about the issue is something really important. And I think that was clear in a lot of the other contaminants as well, as there's a wide variety of stakeholders involved, and that's very important in addressing that.
It seems like for many emerging contaminants, so these three that we're talking about today, the pharmaceuticals and personal care products, sunscreens we're starting to hear about, it seems like most oftentimes we hear of it in places. So we get some information about occurrence first. And then information about, well, is it a problem? And how and why is it a problem seems to come later. And there is a prolonged period of maybe anxiety about, is there a problem or not with this? How do we manage that? Or do we have to throw the whole way we think about it out and come up with a better mechanism so that we get toxicity maybe earlier before discovering these things in the environment?
Very good question. I don't know that I have a good answer for it, but I would say right now for microplastics, we're probably in that anxiety stage still, trying to determine what the broad effects are. I think we have a better understanding now of ecological effects, but the human effects question, I think, is just still being researched a lot and trying to determine that. So I think in terms of a best practice, if those could have occurred simultaneously, that might have been a little bit better in terms of the speed of which things are happening, because I think we're just, like you said, taking that stepwise progression where we found it in the environment, okay, what's it doing in the environment? But at the same time, I wish that we would have at least been looking at human impacts a little earlier.
So my reaction to that is I'd like to see much more stress on the principle of precaution, which is something that's really prominent in Europe and other areas, where we're concerned about compounds that are man-made specifically. I'm not so sure how much it relates to HABs and things like that. But to be very conservative and very concerned about compounds, new compounds that you make. This is the lesson for PFAS compounds. Because once you make them, they're there forever. They're not going to degrade. And if there's any toxicity associated with them, they're going to be around forever in your environment. So we need to think very carefully about what we make, what we permit to be released into the environment, and understand the consequences associated with that. And right now we have sort of a presumption of innocence for all chemicals that are produced to a certain extent, and we want to see disease occurring in human populations or otherwise before we start to take actions to try to control what's happening. And that's antithetical to the principle of precaution, and it's not an idea that's often discussed in this part of the world, but it's sort of the foundational element of a lot of European and Scandinavian thought on pollution prevention and dealing with introduction of new compounds into commerce and into the environment. So I think just emphasizing that thought alone would help us reframe a little bit better.
Yeah, I think I could pick up a little bit on what Andy says too, because that's my experience with the harmful algal blooms. These compounds are considered super toxins, so you don't have to have a very special kind of long-term exposure to see an effect. And so that tended to drive, it was one thing for me to say that they're there, but typically we always responded when some animal died. And so that drove the issue more than trying to be proactive. It's always, the proactive issue is to go back and say, well, what's the problem? And of course the problem is we're neutrifying waters at too fast a pace. And of course we modify and develop waters that set themselves up for growing HABs. HABs are very good opportunists. So they're going to take over in almost all these situations where we create that water environment. But along with Andy, it was clear to me that there was, and it wasn't because the U.S. was ignorant, it was because we had better water, typically, than the rest of the world did. And that tended to drive the issue internationally. And so I wasn't very long before I was out of the country, more I was in the country looking at HABs, and why the World Health Organization picked up and took the, setting guidelines rather than the U.S. EPA. Although I have to say it was the U.S. EPA that set me up with the very first international conference in 1982. So they weren't totally out of the loop. It just, they're waiting for something significant to happen. I think that's what it all comes down to. Unfortunately, all too often, we wait for the disaster before we respond. And that's not a criticism, it's human nature.
And so I'll wrap this up with one more piece, and that's this question. I don't know if you had other questions. I wasn't trying to push you off the stage, Linda. Do we need to think about this differently? Do we need to look at our current regulatory process? There is a lot of discussion going on nationwide about, for example, those steps of the Safe Drinking Water Act. Those take years to get from listing a contaminant on the CCL to formally regulating it at our drinking water plants. And I think there's a lot of discussion about, do we need a different process? Do we need to adjust that process? It's been, that was passed in 1996, and I think it's time to reevaluate it. What the answer is to that, I don't know yet, but stay tuned. I think like I said, we need some innovation and some different thought on this.
Just to piggyback off of that, I heard recently that since the amendments of the Safe Drinking Water Act in 1996, there's been no new chemical regulated that's gotten an MCL. That's been 23 years. So if the PFAS, PFOA, PFOS compounds do become regulated, that'll be the first one that's gotten regulation.
Yeah, and there's been a number of chemicals that have gone through that process. They do the regulatory determination, and they have decided not to regulate, whether it didn't occur in enough frequency or there wasn't a meaningful opportunity to, or the health effects weren't there for whatever reason. There was one, I think, that was moved forward and is in MCL development, that's for perchlorate. But that has been, I think, hung up in the MCL development phase.
So with that, I think I'd like to open the floor to questions from the floor for our panelists. And so we have Joe that's going to be going around the room with a microphone. Yes.
Good morning, thank you. Dr. Francisco Yervides, I'm with River Network. I heard from Dr. Klei about what I agree with Dr. Lindstrom about the paralysis by analysis, the precautionary approach. You need to step up the amount of emergent contaminants that are being considered. As a nonprofit group representing 6,000 groups throughout the country, I wonder if a best practice is to break these ivory towers, to not just be stuck in the very, very detailed analytical way of detecting all these emerging contaminants, but involve the communities affected, involve the industry which is culprit, and create task forces, create working groups, and maybe EPA has some funding available, where the citizens, even though citizen science we know is not as stringent, but can help in accelerate this detection and be involved. Thank you.
Would one of you like to start answering that?
I'll take a crack at it. Thank you for the comment. I think the role of citizen action group and volunteer monitoring, how can they be involved in helping us get the data and involved in the discussions early on is an extremely good point. I will say for Lake Erie and the HABs, we did an initiative where we worked with the charter boat captains to help us. We can't be everywhere from a monitoring agency, and I think that was a very successful public-private coordination piece. In terms of, I think that the one piece that we need to remember is when we start regulating contaminants, there is a cost. There's a cost to communities, and in some cases, I think one of the concerns that I have from a regulatory agency is we are diverting resources from other contaminants and priorities that we have known health effects. It's a balance, and as the science, and that's one of the greatest challenges that we have from a regulatory agency is how do we manage that? And so do we want utilities to spend resources and time away from lead to deal with new contaminants? At some point, perhaps yes, I don't know. We don't have the complete information. But back to the public engagement, we're seeing with PFAS, I think, more a movement to, when we have localized issues, to engage with the local citizens groups. And in some of the other states that have had problems, we're having more of that interaction. And I think you're right that we probably need to have even more going forward.
Just a quick comment to that, because I used and still do deal a lot with organizations. Here in Ohio, I found that in terms of public level input, it was always important because you get contacted by lake owner associations, often drove the initial issue. The problem was they were usually split down the middle as to what they want to do and how much money they have to spend, and almost invariably nothing got done. So I'll leave you with that comment. There are methods, but it really takes something like an oversight agency like the EPA to sit down with these groups and say, well, we have to decide something. And I think, to move it forward, otherwise it often stalemates. Same thing in Oregon. I'm a board director of Oregon Lake Association. That's one of the main things we do. And we're now pushing through legislation similar to what you've done here in Ohio. Through our legislature, currently we have a bill pending for monitoring in Oregon. And I deal with watershed councils often in Oregon. Land trusts and watershed councils often push the agendas on lakes. But it's the same thing. There's some very good people that understand the issue, but it always gets bogged down in those that just don't want to push anything. And it often gets stalemated. You need somebody to come in and say, okay, we do have to do something. I think that's really where it's at. It's, ground root organizations, student organizations are great, but somebody has to be there to make that bigger decision.
So I guess I would react to those comments. I agree with Wayne that there is, I think, obviously a role for federal authorities to sort of set the tone and to try to establish some kind of coherent national plan to deal with these problems. But to the question and the statement by the individual there, thank you. I think a lot of the problems we face are very basic. They're very fundamental. In the case of HABs, it's nutrients, and it doesn't take a rocket scientist to figure out that that's the problem and think about ways to deal with those kinds of problems. So citizen science and observation and participation is crucial, I think, in getting people to understand, the basic mechanisms of why we have, inputs and what happens with the inputs and why we get algal blooms. So I think it is important to go, go from the ivory tower to the street, to the lakeside, and to try to integrate a response. I think that's a very healthy thing because we're all in one ecosystem. Speaking to Amy's comment about costs for imposing regulations, I'd like to say there's also a cost to the production and use of chemicals. And that cost is not being borne by the producers of those chemicals in lots of instances. So if you're producing a compound and you take care of the waste and you manage it correctly, you're not transferring that cost to society, to the municipality, to the person running the wastewater treatment plant. It's actually a cost that's in the production of those materials. And we see this with the perfluorinated compounds all the time. They let the waste go out, into the river, and then it's somebody else's problem. But that's not true. It's actually a cost associated with the production and management of those materials. And you're going to pay the cost sooner or later, someplace, somewhere down the line. And if you can focus it onto the people who are actually making the profit, I think that's a more healthy way to look at the problem.
Just really briefly, I agree. Citizen scientists and citizen science is very important, especially in the marine debris realm. Maybe a little bit easier for me in marine debris because microplastics come from larger pieces of marine debris in a lot of cases. So the bigger things are easy to see. And it's something that the general public can easily recognize and get engaged in. So we do a lot with citizen scientists in our marine debris monitoring project. But also the community level engagement, I also agree is very important. Getting those stakeholders at the table is something that we've strived to do. If you're able to stick around for my talk, I'll talk a little bit more about marine debris action plans that have been developed around the country. We have one particular for the Great Lakes that does include a lot of different organizations, including industry, including local state governments, local NGO groups, etc.
Is there another question? We got a hand up, a couple hands up. This one first, I think.
Hello, thank you for being here. My name's Matthew. I'm a student at Ohio State studying sustainability and business. A comment was made earlier about the new administration and bringing them up to speed, and there's been a lot of comments about the importance of regulation in dealing with these issues. I guess since we have so many new, like every 4 years, 8 years, we have a new administration coming in, is it difficult to get that kind of consistent, lasting policy that we're really hoping to create to address these policies, or have you found that, there's ways to create a policy that will be, resistant to new parties coming in or new changes in leadership?
It's a good question.
So I'll take a stab at that. Yeah, I think it's pretty clear. As Linda said, we haven't had a new MCL since 1996. And we've discovered thousands and thousands of new compounds that we know are a problem. If we're thinking that the current regulatory apparatus is working, I think there's lots of evidence to support the idea of approaching this in a different way. Looking at other countries, looking at other states that have performed actually very well. Specifically with the state of with the perfluorinated compounds, the state of New Jersey is really sort of leading, one of the states that's leading the national efforts right now with making their own MCLs for PFAS, PFOA, and PFNA. So I think there's a lot to learn, and we could have a more robust regulatory climate because of, as you say, the changing political oversight that's there, that's inconsistent and chooses to emphasize different things depending on what the administration is. There's a lot of work that we could do if we sort of reframed our thought on how to address the regulatory approach.
Sorry, I don't know what, just quick to say, I'm not a great advocate for regulation. I much rather see guidelines. I much rather see numbers that can be flexible and then defensively flexible because they're obviously going to change. And I like to see guidelines widely publicized and let the citizen and the public push that issue and to push those numbers and say, okay, we know the toxins are there. What are you doing about it? You say, well, we have guidelines, but we don't have. Setting regulation is just so difficult, and I'm sure.
I agree. It is extremely difficult and time-consuming and costly. And I think it's that cost benefit analysis that is part of the MCL process is something we need to not lose in the end of this. In terms of dealing with transitions in administration, I think that through the HAB program, we've been very successful in getting the state strategy out there. And from administration to administration, that has been successful in getting them up to speed and on so we haven't lost ground. I don't know with PFAS going forward, and it isn't just the state level that we have changes in administration, it's the national level and others. But that is one thing where we try in preparation, as part of the transition to not lose as much speed as we can.
Another question? Let's see. This one, then we'll go over to you.
Yeah, the question I have is on the cyanobacter. What are the promising drinking water technologies to clean it up? And then what are the most promising, such as the phosphorus reduction policies or process that you think that are helpful?
Okay, to the first question, there are definitely technologies to clean up the water. It's just that most utilities don't employ them. For example, Toledo's plant was built World War II, post-World War II. Standard sand filtration, chlorination makes it look better, and most oftentimes it doesn't. But if you get a bloom event, that type of technology just can't handle it. You need the more advanced technologies, dissolved air flotation, ozonation, carbon filtration, and that's what I saw internationally, almost everywhere, far more than I saw it here in the U.S. And, the plant like the upgraded plant at Salina is doing that. I'm sure that Toledo will do the same. So I think, there are the technologies. You just have to employ them. You have to set aside the monies. In terms of, reducing nutrients, there's technologies for that too, but it's largely chemical, and how you treat the water to keep the phosphorus bound up in the sediment so it isn't released and things like that. But in the end, you really have to address where's it coming from and stop that source too. So there are technologies for all of that, and they exist here in the room.
Yeah, and I will say with Ohio's harmful algal bloom rules, I think one of the most important pieces that we put in was requirements for systems to be prepared, and we've got, if they have any detections of cyanotoxins, they are creating treatment optimization plans. And if they have higher levels, they're doing general plans. And what we have seen is out of our nearly 120 water systems that use surface water, we have 70 of those systems that have already developed those optimization plans. In many cases, they have identified the treatments needed and are installing them. For example, Toledo is in the middle of installing that ozone system as we speak. And I think one of the reasons we've been so successful with treating HABs in Ohio is not that our blooms have gone away or that we're testing more than ever, this testing at our systems. The fact that we haven't had the advisories is because of the treatment that our systems have put in place. We've worked hand in hand with US EPA, and my team back there could talk for hours about this, but I won't let them. The types of carbon feed for the different compounds, and we've also as a state put $150 million toward targeted funding to help our systems get these treatments installed. That's how Toledo is putting in their system. Put-in Bay on the island is in the middle of putting ozone in. We've got carbon feeds going in around the state. So that has been one of our priorities and a lot of lessons that we've learned in the state of Ohio. And we're trying to translate that into guidance. We've updated our white papers. We've worked with other partners to share that. We had conversations with your friends in Oregon when they had their little issue there out there in Salem about treatment technologies. So I think that is a very important step in dealing with emerging contaminants, is getting our systems prepared and proactively ready to respond and prevent, at least on the drinking water side of things.
Okay, I think we're going to take one more question for the morning session, and we've already...
Great,
Sorry.
thank you. Hi, Christy Meyer with Ohio Environmental Council. My question is about, there was a comment about the Safe Drinking Water Act and changing the process, and I'm wondering if there's any discussion about putting that burden on the company that's developing the chemical to prove and provide analytics that this chemical is really safe before we put it out.
I have heard there are some discussions, I think, on the national level. TSCA, which is the group that approves those, looking at their process to bring these online. I'm not privy to what those are, but I'm pretty sure that's being looked at. It's an important place to start, and I mean, from a state perspective and representing our utilities, we would certainly like to see more of that.
So TSCA is an EPA process, and it has recently been revised with the Lautenberg revision just most recently. That's certainly the place to start sort of nipping this this in the bud as the new chemicals are rolled out. I don't have direct access to the TSCA implementation, and I don't know that much about it. Although I do know, as it was implemented in the past, as I'll touch on in my presentation later on today, it was not adequate to screening replacement compounds. For example, PFOA was one of the compounds that was being used, and it was replaced with Gen X. And it turns out that the Gen X compound has exactly the same kind of properties, the same toxicity kind of profile, the same lack of degradation in the environment. So it's clearly a problem. It's clearly an area that we need to focus more attention on. And thank you for noticing that, and please continue to advocate for a more robust regulatory apparatus to deal with those things.
Okay, with that, let's thank our panel for this morning. And I think you know that they've just scratched the surface, so please stick around and hear a little bit more about their areas. And I'm going to turn it over to Jeff Sharp.
Thank you. As our tradition at the Environmental Professionals Network, we'd like to present you with a certificate of appreciation. That concludes today's EPN breakfast portion. We appreciate everybody's participation. There will be about 15 minutes until the next program begins, so there'll be some time to network and visit with some folks before we restart promptly at 9:45 with Dr. Wayne Carmichael. For now, please turn to the back of your program to see upcoming EPN events and to read the exciting details for our annual signature event. We're delighted that on April 8th, we're going to be hosting a panel of exceptional speakers who will discuss climate change, environmental justice, and the role of women in the environmental and conservation movement and leading our environmental quality efforts forward. That, for those of you that are regular attendees, realize that event is actually an evening event, and it'll be in Archie Griffith Ballroom, and it's kind of our end-of-year celebration. We'll have 700-800 people there, so it'll be quite an event. Prior to that program, too, if you come early, you'll be able to see some of our undergrad or senior capstone projects, including some hands-on projects from around Central Ohio, focused on water management, among other topics. So please be sure to arrive at the Ohio Union at around 6 p.m. And then looking farther into the future in May, we're excited to have a kind of an offbeat sort of like topic on bringing well-being to communities, and we're going to actually have a leader of the Save the Crew movement here. So if you're interested in something new and different, I'm excited about that May program. So as you make your way to the door, as a final note, this is a zero waste event. Please look at the receptacles and identify where your materials need to go, and if you need some help, there'll be somebody around here that probably knows which receptacle to put in, but we really do try to reduce our solid waste here. So thank you very much for your participation today, and we look forward to sort of hosting more of you at 9:45. So thank you very much.